Healthcare is so important to all of us, to ourselves and to our families, and also to our society. And really, modern systems must reflect the importance of healthcare. The healthcare infrastructures that we've created in this country and around the world really are typically not focused on creating holistic care. So often the systems that we've created are centralised, they're non-integrated, so systems between different hospitals, between primary and secondary healthcare, often aren't integrated together. And when you also include other care systems, such as for police, education and social care, then the whole system really doesn't operate in the most optimal way. It's often ad hoc and it's often reactive. So the healthcare system will often wait till we're ill to be able to do something about it. Along with this, the whole system tends to be clinician focused, in that the patients will revolve around the clinicians and the infrastructure. And there is a great deal of clinician control of the records. What we want to do is to move that away to become a more holistic infrastructure, where the care can be focused on each individual, and that care is focused purely on them. So with our system, we look at distributed patient care. It's holistic, it's focused on the patient, it's preemptive, where we can make certain judgments on certain things and to have data ready when it's actually required. Too often in healthcare, what happens is that we diagnose on the spot. What we want to do is to use data from lots of different sources to be able to focus on complete holistic care. And a fundamental part of what we've created is to focus on allowing patients and their families to have more access, more control of their health care information. So our focus is really around integrating all the different domains. It's around looking at assisted living and understanding that environment. It's then on understanding how a patient might go through the pathway within inside healthcare, into secondary healthcare within hospitals, into primary healthcare in GPs, and also to build an infrastructure around the whole social care of individuals. So our models is very much about defining the rights and identity between each of these different domains, and make sure that the data and information flows between these domains to allow for a better care of the individual, and to allow them to have much more control of their whole healthcare environment. For this, there are many changes that are happening, especially in this country and in Europe, and we have an ageing population, so our healthcare systems need to be scalable and need to be much more holistic as we dip in and out of the different domains within healthcare. Along with this, there's a lack of integration at the current time between primary, secondary and other healthcare infrastructures. Along with this, we have a strong demand to consume healthcare information, and it can be used in so many beneficial ways, such as to be able to plan for our hospitals of the future and to be able to look at the care infrastructures that we actually need. And often we can improve healthcare by basically doing things much better, much faster, and using an IT infrastructure which is secure. And along with this, it is important for us to actually scale the whole system to allow carers and trusted people to be able to get access to the data that they want. So our system really focuses on digital trust and human trust. For us, for digital trust, it's important that we can properly identify individuals and systems, and then we can define the rights that these individuals, these roles, have access to data and information. On the other side, and probably more important, is the human trust. So we build a strong governance across the whole system. We look at micro-infrastructure where we can define rights inside hospitals and between hospitals and across different domains, such as between education and healthcare. And then with this, we define strong clinical services, because for us, doctors and nurses need to adopt the system and show that there is some clinical and business benefit. So we focus greatly on creating strong clinical services which are useful to clinicians.
The main usage of the patient simulator is to test the functionality and the capabilities of our Cloud4Health platform. Furthermore, the simulation of patient data enables the testing of e-health services which integrate directly with our cloud platform. The patient simulator, in essence, is simply a software application which is used to simulate the key attributes of patient data. Patient data which is simulated include the heart rate, blood pressure, temperature, respiratory rate, and oxygen levels of a patient. These are otherwise known as the vital physiological signs of a patient. The simulator uses what is known as a discrete event-based simulation technique for the simulation of this data. The novel aspect of the patient simulator is that the application does not use real-world patient data when testing our e-health platform. Instead, the data is simply modeled against real-world data. The alternative to using the patient simulator for testing and evaluation of our e-health cloud platform would be to conduct what is known as a live clinical trial. In a live clinical trial, we simply deploy the e-health platform in a live environment such as a hospital and let doctors and nurses and real-world patient data interact with it. Although the results obtained from a live clinical trial can be useful, the actual process of conducting a live clinical trial can be rather difficult. This is due to two main barriers. The first barrier is the legal barrier, and this is ensuring that privacy of data laws are being followed correctly by our implementation. And the second barrier is the ethical barrier, and this is, for example, obtaining consent for the patient whose data may interact with our e-health cloud in a live environment. Overcoming these two barriers is not impossible, but it can be a very time-consuming and costly process. By using the patient simulator instead of conducting a live clinical trial, rapid testing and evaluation of our e-health cloud platform can take place at any given point in time. Therefore, by using the patient simulator, we can mitigate the problems of both the legal barriers and the ethical barriers. Currently, we are formalizing the design of the patient simulator to produce a concise evaluation framework. This evaluation framework aims to evaluate any e-health platform, though for the time being we're using this evaluation framework specifically to evaluate the Cloud4Health platform. This evaluation framework aims to provide a precise methodology which enables a wide variety of evaluation metrics to be attained when evaluating an e-health platform. Examples of some evaluation metrics which can be obtained include the scalability of the platform, the cost in using the platform, the response time of the platform, and the ease of usability of the platform. Currently, because the evaluation framework is still under design, we hope to present some results from this evaluation framework in the near future.
Cloud4Health is built as a self-contained cloud computing architecture. It comprises of 4 layers as illustrated by this diagram. The bottom layer is hardware as a service. This layer provides physical computing, networking, and storage resources. On top of this layer is the infrastructure as a service layer. This layer virtualizes the physical resources and operating systems using open source hypervisors like Xen and KVM. Further up is our platform as a service layer. This layer provides SDKs, APIs, and middleware services to help application developers to build their own e-health software as a service.
The core of the system is called the single point of contact, as known as the SPOC. The SPOC is also the foundation of our platform as a service layer. The SPOC opens 3 interfaces, respectively to the system administrators, data owners, also the patients, and e-health applications and their clients. The system administrators can create a flexible and dynamic domain ontology. This provides a vocabulary for the patients to give specific consents on the sharing and the usage of their own data. The patients can give such consents using a friendly user interface in a semi-structured natural language. The policies are then compiled into a formal policy and stored in the SPOC's policy repository. Also, the e-health applications and their clients can make requests for such information, and they can authenticate themselves and then apply for authorization security token. If they are authenticated and authorized, the SPOC issues a token to enable the e-health applications and their clients to get data from data sources. So the entire workflow is like this. First of all, medical data are captured by a wide range of mobile and handheld devices in a clinical environment in real time. These devices implement the Cloud4Health API for secure web services and upload data to data bucket hosted by the cloud computing infrastructure. The sharing and usage of such data are defined by data owners themselves using the Cloud4Health policy syntax. The data owners can allow their data to be used by certain individuals, roles, and e-health applications, or to be synchronized with another system, such as the Microsoft Health Vault. The eHealth application analyzes data, and in case that a clinical incident takes place, the applications are able to push notifications and alerts using our messaging infrastructure to carriers, clinical staff, ambulance, and etc.
The health system is comprised of two domains. There is centralized care, which includes hospitals and clinics, and decentralized care, which includes home care and assisted living. The patient can be in any of the domains, and crucially, the patient moves across the domains. What happens is that any health records that this patient might have to move with him while he goes, for example, from home to a hospital care environment. At the moment, this is happened with the physical records, the paper-based records, and it happens by actually physically moving the records to the new domain. Now, on the bottom of the screen, we can see the proposed system, which is basically an electronic version that mimics the physical system that we have right now and can electronically move the records, and not only the data themselves, but also the identities of the patients and whoever used the system, and access rights to the data. So what we do is that each patient has a single record, and he's the sole owner who can designate who will have access to read or write onto this record, and they can revoke this access at any time. So that lets the patient share the record with their family or their doctor, or if they change doctor, to only to change the sharing rights, and only the new doctor will be able to see the record anymore. So this system is scalable because data stay in the source that created them, and we only define the sharing mechanisms, and we use them only if the patient moves across the domains. That means that it works like the internet, where you only need to share when you want to, and there is no central location that has to store a vast quantity of data. This system is also very flexible, and we have proven that by integrating the Cloud4Health platform with Microsoft Health Vault.